The children, as for the given question, the mass of 10 kg is placed on this inclined plane, and the moment when angle of inclination is 20 degrees, it starts sliding but without acceleration, which means what? Yes, body is moving with a uniform velocity. But don't forget, on a rough inclined surface. Now they are asking us to calculate the acceleration if the angle of inclination is increased to 30 degrees. So here nowhere a coefficient of friction is not given, that we need to calculate. So children, here we have this relation. So mu is equal to tan alpha. So these are relation between angle of repose and mu. What is the angle of repose, children? The angle with which the inclined surface is making with the horizontal surface such that the body starts sliding. So here initially the alpha is 20, right? So this is tan 20 degrees. So here mu is equal to tan 20, 0.364. So this is not given, that we have to calculate. Okay, fine. Now if the alpha is increased to 30 degrees, the body starts sliding with acceleration. So we need to calculate the acceleration. Children, whenever we want to calculate the acceleration, we must calculate the net force acting on the body. Then only we can get the acceleration. So to calculate the net force, children, first let us see the free diagram of the body placed on inclined surface. So this we know very well, right? So here, this is a horizontal component, vertical component, frictional force always opposes the motion, and the normal reaction. So from this diagram, children, so here F is equal to mg sin. Of course, F is not equal to mg sin theta because the body is sliding. So there is no vertical motion. So I can write n is equal to mg cos theta. N is equal to mg cos theta. But here, as the body is sliding, children, yes, net force will be in this direction, which means what here? Mg sin theta value is more than frictional force. So here net force is equal to mg sin theta minus F. But children, we know that F is equal to mu n. Okay, but n value is what again? mg cos theta. Substitute here mu mg cos theta. Substitute here, so it can be mg. This can be here, this can be, sorry, you have to write as alpha, right? Because it is in terms of alpha. It is in terms of alpha. No problem. Okay, it is in terms of alpha. So mg sin alpha minus F is equal to mu mg cos alpha. So this is F net, but acceleration is equal to what, children? F net by mass. So F net is this. In this we can take mass as a constant, right? So common m into g sin alpha minus mu g cos alpha by m. So m gets cancelled. So actually, children, if you have idea, directly you can use this formula also. G sin alpha minus mu g cos alpha. No need to derive actually. You can use this formula directly. Now substitute the values here. So here g also can common, right? So g is 9.8 into sin alpha sin 30 degrees minus mu is mu how much we got? 0.364 and cos 30, children. Cos 30 degrees is equal to root 3 by 2. This is 1.732 by 2. So this, if you can see, this can be 0.866. So that you can substitute here. 0.866. So this can be 9.8. Sin 30 will be 0.5 minus, if you can multiply this, approximately you will get how much? 0.31522 something you will get. So this is 9.8, 0.5 minus 0.3152. So this how much you will get? This will be 0.184. So if you can multiply this, acceleration value will be 1.84 meter per second square. So children, if friction is not involved, then this F term will be 0. F term will be 0. So if they will give you like a smooth surface, so no need to consider the F term, right? Because only the net force, only one force acting along the inclination will be mg sin alpha only. Because as it is mentioned that a rough surface, so you should be very careful where friction is involved. Immediately what happens, you need to consider about the quotient of friction. Okay children, thank you.